Okay, welcome to mini lecture 2 on social development. In this one, we're focusing on how infants represent other people as agents, how they represent agents as having goals and theories and plans of action. Get ready to be blown away by what little infants in their first year of life can do to launch their social reasoning. So, in one of the original studies, really, I think the original study in the category that you've seen a few clips of now that have now led to, 20 years later, lots of studies about moral reasoning in infants and things like that. Here was the setup. You see a hill and a little protagonist, like this little red ball here, and the protagonist is helped by one character and hindered by another character. Every time he attempts to go up the hill, infants would see either the helper helping him up the hill or the hinderer pushing him back down the hill. And the original study had a dependent outcome of which of these other shapes would the protagonist, our little red ball, prefer? Would infants even attribute a narrative to this kind of display? And would they predict future actions of the little red ball based on the story that they just watched? And so the two outcomes were either the red guy moving to the blue guy and approaching him, or the red guy moving to the yellow triangle and approaching him. I don't know why I've cast them all as him. Sorry, just trying to tell the story. And what they found was that infants expected the red ball to approach the helper, and they were surprised and looked longer when the red ball approached the hinderer, suggesting that they had attributed dispositional attitudes to the red ball such that he maybe liked or would be more likely to affiliate with the helper as opposed to the hinderer. Notice also that they counterbalanced which one was the helper and which one was the hinderer in different trials across a variety of studies. So it's not really telling us how children feel about shapes and colors, but it's really telling us about how they feel about the social role of helper and hinderer. So this original study was in 12-month-olds. In a follow-up that you've now seen a few clips of, and there's one on this week's playlist as well, Kylie Hamlin showed similar kinds of events. In this case, you can see the blue square is the hinderer and the yellow triangle is the helper, and it's a kind of a live action puppet show. Not only did infants show surprise when the protagonist approached the hinderer, they also themselves showed a preference for the helper over the hinderer. So if you gave them two options, like a little toy that looked like the helper or the little toy that looked like the hinderer to play with, they very frequently chose to play with the helper. And even if you showed them the helper versus the protagonist or the protagonist versus the hinderer, they kind of developed a rank order of preferences where the helper was at the top of the heap and the hinderer was at the bottom. The other thing that they did was they took it down in age from 12 months all the way down to 6 months of age, where they could see these preferences consistently. So what is it that we think that infants are making of these little shapes that move around? What kind of theories and dispositions are they attributing to them? So Garrigues followed up on these kinds of shape-based animations and showed infants something that looks like this. I'm obviously recreating it in PowerPoint. So there's this red guy and there's this blue guy, and what you're going to see is the blue guy sort of calling to the red guy, and I think in the originals they could there was a little bit of noise, and there's a wall preventing a direct path. And so the blue guy does something to call attention, and the red guy jumps over the wall in order to get to him. And so infants were familiarized by this kind of display a number of times. And then they saw one of two events. In one, they see the blue guy call attention and the red ball take a direct path. So it's the same as what the red ball did before, in that it's taking the most direct path to get to the end state. But it's different in the sense that it's a different shape that he's carrying out. Or they would see, now that there's no wall, the blue guy turn and the red guy basically show exactly the same spatiotemporal trajectory as before, the same physical trajectory, even though there's no wall. And the question was, would infants be surprised to see that the red ball jumps even though there's no wall, or would they be more surprised at the novelty of the new physical path when it goes in a straight line? And what they found was that with the wall removed, infants looked longer when the red ball jumped, even though visually it's a very similar display to what they were habituated to. And what Gergely and others concluded from this is that infants inferred that the red ball had a goal, which was to get to the blue guy, and that the red ball should take the most direct path to that goal. And they were surprised if it chose to deviate from that path. So what we take from this, at the very least, is that infants are making computations about how self-propelled objects move and why they move. So at the very least, infants are not just memorizing the physical trajectory of the red ball and being surprised if it goes on a new physical trajectory. They're doing something more complex than that. Are they taking a direct path to an endpoint? Is this a sense in which infants are attributing rationality to the red ball, that it's going to take the most rational path, the one that makes the most sense, the one that's most direct? Are they attributing a goal? Are they thinking this red guy really has a goal of getting to the blue guy, or a desire to get to the blue guy? And it's hard to know exactly how much depth and richness to attribute to infants in their reasoning about the red ball as an agent. And Gergely said, at the very least, we can attribute to them that infants have a theory of rational action, that agents are going to act in a rational way to get to the desired endpoint. Interestingly, as an aside, Gergely headed up a really spectacular cognitive development lab at Central European University, which was based in Hungary. But the political climate in Hungary has made it such that the university has not been able to maintain its support, and it's moving to Vienna. And it's really a sad state of affairs because for a number of years, it's been just a spectacular international center and hub, not just of cognitive development, but particularly of social cognitive development, along with his colleague Chibra. Okay, so what is it that 6-month-olds can really think about goals? Here's another study that gives us a little bit of insight from Amanda Woodward. In this study, children would see a live action display where they didn't see the actor, but they would see an actor's hand. There would be 2 objects that the actor could reach for. In this case, what you can see is a ball and a bear. And they would see the hand reach over and over again for one of the objects. Half of the infants saw the hand reach for the ball, and the other half of the infants saw the hand reach for the bear. So there's 2 different habituation conditions. In the test, they reversed the positions of the objects. So now, on the left-hand column, if the hand continues to reach exactly following the same physical trajectory as before, it will now grab a new object. And on the right-hand column, if the hand continues to reach just as it had before along the same physical trajectory, now it will reach the ball, a different object than what it had reached for before. And so the question was, do 6-month-olds have a theory of reaching such that they expect a reach to have a target, not just of a location, like this hand goes to this place, but of an object. This hand is reaching for this object. And it turned out, as you can probably guess by now, that infants who were habituated to a hand reaching for the ball were surprised when the locations were switched and the hand reached for the bear. But they were not surprised when the locations were switched and the hand reached for the ball, even though the ball was now in a new place, as though they inferred that this hand wants this ball, its goal is this ball, its desire is this ball, the target of its reach is this ball, and why would it reach along the same physical trajectory to a different object? Notice that the visual dynamics of the display, right, change when the objects change. And so really, if you look at those two left-hand boxes, they look so similar to each other. And that is what the infant saw too. And so it tells you how strongly they must be encoding the goal of the reach in order to be surprised when the hand follows exactly the same motion that they've seen it follow a whole bunch of times during familiarization in order to grab a new object. They were like, that's not what this hand has been reaching for over and over again. I wonder why it's doing something different now, even though the physical trajectory is so similar and the visual stimulus that's coming in to the infant is so similar as what they saw before. So the inference of this is that 6-month-olds interpret reaches as goal-directed, and they're surprised when the goal of the reach seems to change. Interestingly, there's been, of course, the first of the sticky mittens studies was about this, and so younger infants who don't show this pattern of looking, if you give them sticky mittens where they learn how to reach and that reaches help them to grab things, even if they're not really good at reaching by themselves, you can change their pattern of looking to the more sophisticated one you see here just by giving them more experience with reaching. That's how they come to understand that the target of a reach is for a particular goal object and not just to move your hand in a particular way. So hopefully I've convinced you by now that infants, even by 6 months of age, have a fairly sophisticated understanding of other people's goals and that hands have goals. And another element or a kind of wedge into this kind of social understanding of goals comes from looking at imitation. So I'm going to show you one of the first imitation studies. This is Andy Meltzoff looking at newborn infants just a few hours old, and he took facial expressions that infants already make spontaneously right after being born: tongue protrusion, open mouth, and lip pucker. And so since we know that infants are capable of making those facial expressions, he tried to see if infants are more likely to make them in the few seconds or a minute after they see an adult model make them. In other words, if they're likely to imitate from birth. And that's what he did, and he coded the frequency of these facial expressions, and he concluded that they were more likely to make the one that they had just seen. Okay, having a little bit of glitching here. This finding has become controversial as other people have tried to replicate it, but in any case, it gives you a sense of one of the original imitation studies. So we can use imitation as a lever to try to understand what it is that children think other people's goals are or think their actions are about, because how they imitate and what they imitate tells us what they think the event was. So in this classic paper, Gergely again showed an experimenter turning on a light with her head. In one condition, she said, "Oh, I'm cold," wrapped herself in a blanket, and then turned on the light with her head. And in a different condition, she didn't say that. She just had her hands free. They were on the table, and she turned on the light with her head. So before you go into the next video, I want you to think about what kind of information about the goal is a child getting from each condition.